This week's assignment is to implement part of the k-means algorithm. Hopefully you reviewed the Unit 6 lectures from Stanford on that. The first couple cover the k-means algorithm. You can download the initial file as part of this assignment that implements some of it, but you have to implement more of it. Here's a review of what you get. You're given a set of data points called data and a set of clusters called cluster, an array of those. K is the number of clusters you're given. You're given a set of initial data points. There are 15 of them, and here's kind of a view in Excel of those data points. There's some larger trees we call white pine trees. There's some middle-sized trees we call maple trees. There's some small bushes and some really small shrubs, and we're going to try to cluster those without knowing the actual categories. There's a routine here that initializes the data and initializes the means. There's another routine here that finds the nearest mean to any data point. So it assigns each data point to a cluster. It checks out all the means and sees which one's closest. And there is this routine called update cluster, which you will have to implement. So your job is to write this update cluster center routine. You're given a cluster M, and you must look through all the data points, find the data points that have the data type equal to M, and then you have to find the average X and Y values for those data points. You have to set cluster sub m.x equal to the average of all the X values, and the same for Y, cluster sub m.y equal to the average of all the Y values when the data values type is M. So you have to look through all the data values, check if their type is M, and if so, average out all their X's and Y's and set the cluster M sub X equal to that. Now there is a problem. There might not be any data points in this cluster, so calculating the average when there's nothing gives you a problem. So if there are no data points in your cluster, so you search through and there's none of the data points have their type of M, then you must reset the cluster to a random point. All you have to do is call cluster sub m.setRandom, and it'll reset it to a new random location. So you have to implement those routines. There's a main program down here that calls the initialization routines and calls find nearest mean repeatedly, and calls your cluster center, update cluster center routines that you're writing for each cluster, and then displays the cluster. When your program is working, it should run and it should break the data up into different clusters. So here we've got k equal to 2, and so we have two clusters, the white pine cluster, and it grouped all the maple trees, bushes, and shrubs together. It's kind of random every time. It might break it up into different clusters. Like this time I ran it and it put all the bushes and shrubs together and all the trees together. You can try this out with k equal to 2, try it out with k equal to 3, and also do k equal to 4. So you can change the k up at the very top of it and run it multiple times, and you'll get different clustering depending on what k value you have.